Hey everyone, welcome to classwork or lesson 7.4, where we'll be talking about natural logs and E. I'm going to make the assumption that you watched the video on the lesson page right before you watched my teaching lesson that explained to you where this idea of E and natural logs came from, what happened in history about why this arose and why they had to figure this out, and the purposes for it. So I'm going to assume that you watch that video first, okay? And we're going to talk about how to use it a little bit and do a couple of practice questions from the classwork. So the first thing I want to do is I just want to quickly review with you that remember when we were talking about logarithms. Remember we said that if we had x equals b to the y and converted that into logarithm form, that the b becomes the base of the log, the x is what comes next, and then the exponent is always the answer. Okay, so we'd have log bx equals y. And we put some numbers with that just to demonstrate. The one we were using all the time was 9 equals 3 squared. We're going to take that and write it in logarithmic form. The 3 becomes the base of the log. The 9 goes here, so we get log base 3 to the 9, and the exponent is always the answer to the logarithm. Okay, so in the same way, I want to introduce you to natural logs work pretty much exactly the same way. If you understand this, if you understand how to use logs, then you will know how to do natural logs. They work the exact same way. So just as a basic pattern, okay, so instead of saying x equals by, let's take a look at x equals e to the y. So instead of using a logarithm, we're going to use E and natural log are still logarithms, okay? But their base is E instead of using logarithms, okay? So if we have x equals e to the y, to put that in natural log form, similar to this, instead of writing log, we use a natural log to the x. So natural log x equals, and just like logarithms where the exponent was the answer, it's the same idea. The y, the exponent, is the answer. Works the same way. Now what is different is that e has a very specific value. E to the 1 power, as you were told in the video before watching this one, so e to the 1 power has a value of 2.7182818, blah, 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 so on and so forth. If you want to see this number for yourself, you could just simply take your calculator, find the E button. You'll probably have to hit second function ln, which is probably the E button on your calculator. Second function ln, and hit enter, and it'll give you this number, okay? So let's play with this. A couple things I want to show you right off the bat before we do anything else is just take your calculator and do a little practice with me here. Pause the video if you need to. I would like you in your calculator, I would like you to do the natural log, okay? The natural log of, I'll put the parentheses because in your calculator it's going to use parentheses. I want you to do the natural log of e to the 1 power. It's kind of a dumb question, but I want you to actually put that in your calculator and see what the natural log of e to the 1 is. If you need to, pause the video. I really want you to try this. So e, do natural log, e to the 1 power in your calculator, and you'll see your calculator should tell you the answer to this, the natural log of e to the 1. The answer is 1. Okay? Now, you almost didn't need to use your calculator because if you look at the pattern right here, you will know that the y, the 1, is the answer. Okay, but what I want you to see is that natural log and e sort of cancel each other out almost. Not, I mean, I want to say it that way, but that's not entirely mathematically correct. But if you think of it like natural log and e, they're opposites and they cancel each other out whenever you put them together. In the same way, if you take e, do it in your calculator, if you do e and raise it to the ln1, okay, if you take e and raise it to the natural log of 1, it's going to give you the same answer. It's going to tell you the answer is 1. Right? I like to, I kind of take a shortcut here, and I kind of just think about that e and natural log. E and natural log are kind of opposites. When you put them together, you're always going to get a 1. And you're going to see I can use that to your advantage in just a minute. Now, because natural logs work the same way as logs, what that means, and this is very important right here, because they're almost the same, okay, let me just draw a little arrow here, coming off of my natural logs here. This means that all the properties, okay, the properties of logs, the properties of logs work with natural logs. Okay, ln for natural logs. I believe it's Latin for I don't know what, but in Latin they put the log word first and the natural word second. So in Latin, that's why it's ln and not nl. You know, in English we say natural logs, but it's ln for natural logs. Okay, from the Latin, I believe. Properties of logs work with natural logs. That means, remember the 3 properties that I taught you a couple lessons ago? That means that the product property, the quotient property, and the power property. Okay? The product property, quotient property, power property, they all work with natural logs exactly how they work with logs. Okay? Now, I'm not going to write out the 3 properties for you again. Just flip back in your notes. Where you wrote down the properties with the word log in it, just take log, take out the word log, and insert ln. That's all you have to do. Okay? Take out log, insert ln in place of log, and you have the same properties all over again. All these properties work with natural logs, the same as they do for logs. Let's do an example so I can demonstrate for you. Let's say that we have, okay, I just need to get, oh no I don't. We'll just make one up. Let's say that I have, let's make a question up. Let's say I have 3 natural log of 12 minus, wait, that's going to be too hard for me to do without a calculator because I keep realizing that I don't have a calculator in here. Let's make up one that I can do without a calculator. Let's say that I have 2 natural log, how about 6? 2 natural log 6, and I'm going to take away natural log 3. That's one I can do without a calculator. The ones in your practice questions will be a little more difficult, but let's look at this question here. We're going to use these properties to see if we can simplify this. So obviously, you'll notice that on the front, we've got a 2. That's going to be the power property, where we're allowed to take a number on the front and move it to become an exponent, just like we did when we were practicing with logs. So we're going to use the power property and move the 2 to become an exponent right here. So I'm going to rewrite the question as natural log of 6 squared minus the natural log of 3. Now, you will notice that we have a minus sign here, and you know that minus signs go with quotient property. But before I use the quotient property, let's actually figure out what that is. 6 squared is 36. So the natural log of 36 minus the natural log of 3. Okay? So, natural log of 36 minus the natural log of 3. So, you guys remember from practicing with logs that minus goes with quotient. And we can change a minus into a division problem. So we're going to do that. This becomes the natural log of 36 divided by 3. Now, Little note here, because I notice that sometimes students make this mistake. Notice that I wrote one natural log and then the numbers. I didn't put, what I did not put, notice what I did not put was natural log of 36. Let's actually write it here. Notice I did not do this. Natural log of 36 divided by natural log of 3, okay? I did not write that. I wrote one natural log with the 36 over the 3. That is the quotient property. This, you can't do this. This is not the quotient property. Now, can we simplify this? What is 36 divided by 3? Well, 12 times 3 is 36. So 36 divided by 3 is the natural log of 12. Now, I don't have a calculator, but if you took your calculator, you could, in your calculator, simply type natural log of 12 in your calculator, get an answer. It might be a decimal or something, and you could write it out, maybe round it off to something. But that's how we use the properties, okay? Now, to finish, what I would like to do is I would like to actually do some of the questions from your practice work. I'm going to grab the red marker to do those, and we're going to go over here. So, from your practice questions, which you will see there's a PDF for you to download, from the practice 7.4, this is number 11. Question 11 is 3 natural log of 5. And the question says to write the question as a single natural log. So what you're going to do is you're going to use these 3 properties for this section of work where number 11 starts. You're going to be using these 3 properties to reduce them down to one single natural log. So for this one, there's only one thing we can do. It's the power property. The only thing we can do is take that 3, okay, take that 3 and move it to become an exponent right here. That's the only thing we can do to it. So we're going to do that, and we would have natural log of 5 to the 3rd. Now, you could technically take your calculator, do 5 to the 3rd. You could figure that out. 5 times 5 is 25. 25 times 5 is 125. So you could write this as natural log 125. And that's all you can do to it. And we've accomplished what the question said, natural log 125. Now, the ones beyond 11 start to get a little more complicated, but use those 3 properties and try to get down to just one natural log, okay? Number 20, skip ahead to number 20. Number 20 says natural log of 3x equals 6. Now this one's actually asking you to solve what is the x. So this is where we're going to bring what I was talking about here, where natural logs and e's cancel each other out. We're going to bring that into the equation here. So what we're going to do to solve this is we can't solve this unless we get rid of this natural log. How do we get rid of a natural log? I'm just pausing for a second on purpose. I want you to think about this for a second. How do I get rid of a natural log? I can't solve it like this. I can't get that x isolated unless I make that go away. How do I make it go away? Well, natural log and e, we said, you put those together, you get a 1. Maybe we should take the e of both sides. So if I take the e of this side, e and natural log are going to cancel each other out, and we're going to have just 3x. But I have to take the e of the other side as well. I can't take the e of this side and not take the e of the other side. So I'm going to take e of this side, which would be e to the 6. Now I can solve it. I want to isolate x though, so to isolate the x all by itself, I'm going to divide by 3. That means on the other side, I must divide by 3. So my 3's are going to cancel out, and x is going to be equal to e to the 6th power over 3. Now, very important point that I want you to remember when you're doing these is don't think of e as a variable. E is not a variable. E has a very specific value, and we know what it is. Okay, E has a very specific value. It's not a variable, although we treat it like a variable when we're doing the questions, but it is not a variable. You can simply take your calculator go e to the 6 in your calculator, hit enter, find out what that is. Find out what e to the 6 is in your calculator, then divide by 3, and then I want you to write your answer. So x equals, and do e to the 6 divided by 3. I don't know what that is off the top of my head. You're just going to put the answer there from your calculator. Obviously, maybe round it to the thousandth or something. Don't write, the whole decimal. Round it off a little bit. Let's skip ahead to number 29. Now 29 is like this one, but it's just the opposite. Instead of having a natural log, we have e in the question, but we're going to use the same principle to figure them out. We're going to have to get rid of the e to be able to solve for the x. And how do you get rid of an e? You take the natural log to make it go away. So we're going to take the natural log of both sides. So we're going to do the natural log of e, which would cancel it out, right? Actually, I shouldn't have even... I'm curious. Can I erase this with my finger? I can. I didn't know I could do that. Okay, so the natural log of e is going to cancel out, and I'll have just x left. But if I take the natural log of this side, I have to take the natural log of the other side. So this was really simplistic to do, because now I just take my calculator, x equals, punch in your calculator, natural log 18, get an answer, whatever that is, just write that down right there. And that's it. Now, I just did the first ones, which are kind of simple. Just use your algebraic skills. You should have the skills to be able to answer these types of questions. Isolate the e or the natural logarithm by itself first. Okay, before you try to take the e or natural log of each side. Isolate the thing with the x by itself first. So you might be doing, adding 5 to each side or something to isolate it first and then do the thing. But you should all be capable of answering 20 and 29. But I know this is a little bit more difficult than what we've been doing. So please remember that if you get stuck, I'm available every day. Let's go through the steps. You have questions, you're stuck on, number 22 or something. You don't know how to do it. I'm stuck. On the Canvas page, okay, on the left-hand side of your Canvas page, you have your icons here. I forget what they all say, but down here a little bit is the calendar. Click the calendar button in your Canvas. Make sure that, now on your screen when it brings up the calendar, on the right-hand side, you will see it lists your courses. One of them will say Algebra, Algebra 2. You'll see your other courses there listed. Make sure the little tick box next to it is filled in. It'll be filled in with some random color. On mine it's green, but I think Canvas randomizes the colors for you. Yours might not be green, it might be a different color. But look for the course, Algebra 2. Make sure it's highlighted so it's showing you stuff in the calendar from Algebra 2. Tomorrow is the what? I've lost all track of time. I don't even know what tomorrow is. What's tomorrow? The 10th, 11th? I have no idea. So let's just pick April 10th as an example. You will see on April 10th, if you have mine clicked, you will see it says something like 9 a.m. or something. It says 9 I just think, and it says something like questions. Oh, I can't write that small, sorry. Questions and answers. You'll see it says it right there. All you need to do is click on it. When you click on it, it brings up another box. There's a link in there for Teams. Just click on the link in Teams. It'll want to open Microsoft Team Chat. Click on it, join the team chat. I'll already be in there because I'll be in there from 9 to 10. Go in there. You can ask me whatever question you want. I can bring up a whiteboard. I can demonstrate for you, help you figure out some of these problems. I'm actually expecting that a lot of you should be contacting me because this is not as easy as it seems. So if you need help, that's how you get it. I'm expecting to see some of you guys in chat. Do this. This is going to end the unit. Next week we'll be doing a review and the unit test. But we'll do the review first on Monday. That'll be posted on Monday. The unit test will be posted later in the week, next week. But review will be on Monday. You'll have a chance to go through the review and ask me any questions. That's it for today. So try this. Make sure you do the practice questions first before doing the quiz. Then the quiz counts as your 7.4 classwork. All right, any questions? I expect to see you guys in there. Take care and work on this.